We're going to present to you Newton's equation and try to derive formulas, or at least one formula in this first video, from this graph. As you can see here, we have a graph of v, speed, versus time. We see that we have an initial speed, not at zero, and a final speed up higher for a period of time. We can look at the surface area under the graph as two different shaded areas. A triangle, such as this, and a rectangular area over here. As we move, we can see that the area is, for a triangle, 1/2 times the base times the height, and therefore we have 1/2 times the base, which, coming back here, is delta t, times the height being vf, which is all of this, minus vi, which is from 0 to here. So therefore the height is this portion. So we have the following formula: 1/2 times delta t times vf minus vi. Then we can follow this by doing the rectangle, and the rectangle is more easy to follow: base times height, which is again the same delta t times the height over here, which is from 0 to vi only, such as this. Now for the whole area, we therefore have the triangle plus the rectangle as such, and therefore 1/2 vf minus vi times delta t, which is our triangle, and our rectangle, such as this. We can follow this with the following statement. We know acceleration is the change in speed over time. Therefore, vf minus vi over delta t. So then what we can do is move delta t over to the left. So delta t times a will give us vf minus vi. This is helpful to us because then we can do a substitution of variables, and over here where we had vf minus vi, we now put a delta t. We therefore get 1/2 a delta t, and the rest of the formula remains the same. We can see that we have delta t times delta t, so delta t squared over here for the total area, and we therefore present to you the first equation, which is, as you can see here, formula number 1. So now, if we use the formula we have just derived from the graph, we have an example. A car travels at 10 meters per second, accelerates at 1.5 meters per second squared for 10 seconds. What is the distance traveled? Using the given required solution way of solving a problem, we have therefore vi equals 10 meters per second, a is 1.5 meters per second squared, time is 10 seconds. We are looking for the distance traveled, and we're using our formula. We put in the values: initial speed, time, acceleration, and therefore we get the following. So the time is time squared, so it becomes 100 seconds squared. Now we have our units that we can cancel. The seconds cancel over here. Seconds squared canceled with the second squared over here. So 10 times 10 is 100. 1/2 times 1.5 and 100 is 75. As you can see, we have meter units that are left, which corresponds to distance, and we therefore have, as a final answer, 175 meters for this example.